This is a review of various topics from the trigonometry unit in Algebra 2. The first thing we'll review are unit circles, and then we'll look at the graphs of sine and cosine. So first of all, with unit circles, if you can establish a unit circle, you might have to memorize values on this, or you might be given a unit circle like this in whatever course you're in. But when you have a unit circle like this and these values, you can then determine different trig values because we need to use certain identities that we have in trigonometry. And one of them is that tangent of theta is equal to sine theta over cosine theta. Another one is the reciprocal ideas, and since we know that cotangent is the reciprocal of tangent, we know that if you flip this fraction, you'll get cotangent. So cotangent is equal to cosine theta over sine theta. Okay, and then those two we can use to get values off of this. Then the second set will be the other reciprocal values that we know, identities. So one of them is that secant theta is equal to 1 over cosine theta, and that cosecant theta is equal to 1 over sine theta. So these identities are helpful for finding values, because if we have this unit circle, we know that the first value in the unit circle is cosine, and the second value is sine when the radius of the circle equals 1. That's called a unit circle. Okay, so we'll call this a unit circle. All right, now, given this unit circle, we want to find different values. So we're going to look for these values. What I'm going to do is I'm going to demonstrate these, and then it'd be good if you pause the video when you got to the practice part, you try them, and then I'll show you what those solutions are. So cosine of 315, what you want to do is first of all go and find 315, which is right here in the fourth quadrant. And then we're going to just use the fact that cosine is the first value. So cosine of 315 would just be the square root of 2 over 2. So once you know this unit circle, there you have the answer right there for you. Now if we want to do sine of 3 pi over 2, this was in degrees, this one's now in radians. Notice on this one, 3 pi over 2, that value there. So if you want sine of 3 pi over 2, you want the y value, which is -1. So -1 would be our answer for that one. Now tangent's a different story. We've got to go to 60 degrees and recognize that since tangent is sine over cosine, we're going to look for sine of 60 degrees and put it over cosine of 60 degrees. Now finding those values, what we can do is make a fraction of with the fraction, the numerator and denominator. Sine of 60 degrees is square root of 3 over 2. And cosine of 60 degrees is 1/2. Now, we have to remember the algebra of this is that when you have a fraction in the denominator, you multiply by its reciprocal when you bring it up top. So we're going to take that 1/2, flip it over, multiply the 2's cancel, and so we're left with just the square root of 3 for our answer. And then lastly, let's try cosecant of 5 pi over 6. So we're going to find 5 pi over 6 is right here in the second quadrant. So that's going to be, when we do that, we're going to think of 1 over sine of 5 pi over 6. Now, sine of 5 pi over 6 is the y value here, so it's over 1/2. We do the same process of taking the denominator, multiplying by its reciprocal, so times 2 over 1. And so we get a value of just 2 for that one. So that's how you use the unit circle to get these values. And again, this is if you're given the unit circle. In some cases, you might be expected to memorize this That would be a different lesson of kind of the techniques for looking for the patterns of things that are repeated and using your reference angles. But for now, given the unit circle, this is how you find those values. Now what you should do is pause this video, take a look at these practice problems down here, and try to do these practice problems using this unit circle to come up with what these values are. So pause the video and try these. Now that you've tried these, let's go ahead and take a look at what those answers should be. So sine of 240 degrees, here's 240. We're going to take the y value for that to get the sine. So it's going to be negative square root of 3 over 2 for the answer. Cotangent, remember, is equal to cosine of 5 pi over 3 over sine of 5 pi over 3, the reciprocal of tangents. So now once we get that, we're going to go to 5 pi over 3. You're going to find 5 pi over 3 right here. And we're going to put the sine, which is the y value, excuse me, the cosine, which is the x value. So the first one, so that's going to be 1/2 over the sine of it, which will be negative square root of 3 over 2. And now we're going to multiply by the reciprocal of the denominator, so negative 2 over the square root of 3. The 2's cancel, so that gives you negative 1 over the square root of 3. The negative can be in the denominator, it can be in the numerator. Now, this is an answer, but we should rationalize it. So we're going to multiply it by square root of 3 over square root of 3 to get the square root out of the denominator. It would be negative square root of 3 over square root of 9, which is just a 3, which is our answer for that one. Cosine of 3 pi over 4. Let's go find 3 pi over 4. So here's our 3 pi over 4. We're going to do the cosine of that one. So that's just equal to negative square root of 2 over 2 for an answer. And then let's do secant of 90 degrees. Now remember, that's 1 over cosine of 90 degrees. And if we go to 90 degrees here, cosine's the x value, so that's a 0. So 1 over 0, you can't have 0 in the denominator. So if we have 1 over 0, that's going to be an answer of undefined. So using the unit circle, whether it's memorized or not, you can use the values on the unit circle to come up with different trig values that will help you determine what their value are from the standard repetitive sine and cosine, where cosine is the x value, sine is the y value. All right, so after a unit circle with radius 1, we're going to go on to doing some graphing and review. So now we're going to take a look at graphing sines and cosines and looking at how the amplitude and the period can change. This does not include any translations yet. So if we're looking at this first one, we want to know what the amplitude is. So the amplitude is just that first number, which is 20. So the graph is going to go up to 20 and down to negative 20. Now this 9 on the inside affects the period, and since this says we're going to do it in degrees, our period is going to be equal to 360 divided by that 9. 360 divided by 9 is 40 degrees. So one period, I'll put right in the middle here since I have to do 2 of them, is 40 degrees. Now we want to go with half of that, and then half each one of these to get the key points for the graph. So half of 20 is 10 degrees. Now that we see we're going by tens, 10, 20, that would make 30 degrees here. Let's lay out another period out here. So that would take us out to 80 degrees. Split that in half and do half of each of these two. We're going by tens, so that would make this 50 degrees, 60 degrees, and 70 degrees. Now when we do the graph of this then, sine starts at the starting point at the middle, goes to the top, then to the middle, to the bottom, to the middle. That's one period. Then we'll go to the top, middle, bottom, and to the middle. And so our graph looks like a sine wave there's our graph of y equals 20 sine of 9x, having a period of 40 and an amplitude of 20. All right, let's try this next one. Let's do 3 cosine of 1/6 x. So this one, our amplitude is going to equal the 3 in front, so it's going to go up to 3 and down to -3. Then next we're going to do 2 periods, but we want to start and do it in radians. So our period for this one, we're going to start with 2 pi, and we're going to divide it by 1/6. One more time, when you divide by a fraction, you're going to multiply by the reciprocal of the denominator, so that keeps coming up. 2 pi times 6 gives me 12 pi for a period here. So I'll put 12 pi right here in the middle. Split that in half, I get 6 pi. Split that in half, I get 3 pi. Split these two in half, it looks like I'm going by 3 pi, so 3 pi, 6 pi, 9 pi, then to 12 pi. Then take this period, we'll go out another period. That'll take us out to 24 pi. Split that in half, and then these two in half. I'm going by 3 pi still, so this will be 15 pi, 18 pi, 21 pi, and then 24 pi. Now when we look at the graph for this, cosine starts at the top, up at the amplitude, goes to the middle, then to the bottom, to the middle, and then to the top, following this pattern of the wave, going through the middle, to the bottom, through the middle, and then back to the top. So the graph will go like this, and end up there, where we got 2 periods of cosine graphed. All right, let's have you pause this video. You try this next one. See if you can graph y equals 4 sine of 2x for 2 periods in degrees. So pause the video, give it a try. Now that you've tried it, let's have you check how your answer came out. So let's do our amplitude first. Our amplitude is going to equal 4, and then our period, and we're in degrees here. So we're going to take 360 divided by the 2, that will give me 180 degrees. So we're going to go up to 4 here and down to -4. And I'm going to go to 180 here for my period. Half of that is 90, half of that is 45, and halfway between that I'm going by 45, so I have to take 45 plus the 90, it gives me 135. And then I keep going. I'm going to go another period out here. That'll take me out to 360, or double the 180. Halfway between those and half again. I'm going by 45, so 45 added to this is 225. Then the next one's going to be 270. Then 315, adding the 45s on and out to 360. Now let's get our graph. Since it's sine, I'm going to start on the middle of the graph, go to the top, to the middle, to the bottom, to the middle midline, to the top, to the middle, to the bottom, and back to the midline. So my sine graph looks like this. Okay, so what I've done now is notice that I haven't used a calculator. These are all finding these unit circle values by using your unit circle to come up with cosine or sine, and then using your identities, and then also doing graphs so that you can see how to use your amplitude and your period change to come up with your standard graph to get the period, 2 periods listed on this, and how we change the period and how we list the amplitude to come up with our trig graphs.